कैसा फिल्म
क्लिक नहीं हो रहा मतलब घबरा नहीं है।
क्या कर रहा है? ऐसे रहता हो
घबरा नहीं लगे।
हेलो। अरे अब क्या करना है?
अपना स्टाइल, your own style should be bring yourself. Nobody's giving.
ना अब क्या कैसा बोलना भाई?
Right.
Good morning, students. My name is Sampath Kumar. I am senior lecturer, physics lecturer from MS Educational Academy. Today we will discuss few topics from intermediate first year, upcoming annual examination, supplementary classes. Purpose I am giving few important questions explanation from MS Educational Academy. Today we will discuss few topics from intermediate first year, upcoming annual examination, supplementary classes. Purpose I am giving few important questions explanation from MS Educational Academy. Today we will discuss few topics from intermediate first year, upcoming वो स्टाइलर नहीं है सर, वो भी पेन है। हाँ। Okay. Good morning, students. My name is Sampath Kumar. I am senior lecturer physics from MS Educational Academy, Hyderabad. Today we'll discuss few questions from intermediate first year for upcoming supplementary examination purpose. So today this class starts with LAQ, long answer questions for upcoming supplementary examination. Just 5 LAQs, total 5 LAQs, most important questions there in intermediate first year. First, number 1 question from mechanics part, law of conservation of energy, freely falling body. For each and every LAQs, we are having fixed problems. For example, last time annual examination, previous recently wrote annual examination. In that one, 3 questions came. Collision concept. Collision, develop the theory, one-dimensional elastic collision. That question belongs to mechanics zone, work, power, and energy. From that work and power energy, more 2 LAQs, 3-star question there. In that one, first question, law of conservation of energy, freely falling body with bullet problem. So today I will give you complete explanation about law of conservation of energy, freely falling body. Now upcoming questions, define work, kinetic energy, work energy theorem. So from mechanics, one more second important question, define work, kinetic energy, work energy theorem with 2 fixed problems. One is the power of motor in HP. In horsepower, they're asking what is the power of motor. This one 170 HP, and one more, what is the one more problem? Because from these 2, we are getting one problem for this fixed question in annual examination. One problem power of motor, and one more problem again, that one also power of motor, 15 kilowatts, 15,000 watts. So finally, for 19th bit purpose, examination purpose, we are getting 2 important questions from first year. And third question, Newton law of cooling. Newton law of cooling with surrounding temperature problem. 28.3 degrees Celsius. And one more is their question. Total 5 questions. Law of conservation of energy with bullet problem. Second one is there. Define work, kinetic energy, work energy theorem with power of motor, 2 problems. And the third one, Newton's law of cooling with surrounding temperature. Fourth one, reversible, irreversible process with Carnot's theory. This fourth question without problem. The reason means this one already very big answer. So total 4 with one more extra from oscillation lesson. time period of simple pendulum. Time period of simple pendulum with fixed problem, time period of pendulum, students. So later we'll discuss about that one. Today, every student focus on law of conservation of energy, freely falling body, bullet problem. All these questions, 3-star question. From this 5, minimum you are getting 2 questions for upcoming examination, student. So I will give you detailed explanation about law of conservation of energy, freely falling body with bullet problem. Focus on board. Say law of conservation of energy. Law of conservation of energy in the case of freely falling body. We'll show law of conservation of energy in the case of freely falling body. So case freely falling body. Say first statement. You know, law of conservation of energy. Conservation. Conservation means constant. Always, what is the meaning of conservation means constant. For example, in this classroom, you take tube light. In tube light, light energy there and one more electric energy there. By using electric energy, we are getting light energy. Electric energy converted into light energy, that is conserved. Conserved means constant. Energy always conserved. From lower class, you are reading very popular statement. Every student, they know the statement. What is the meaning of law of conservation of energy means energy neither created nor destroyed. Energy changes from one form to another form. So energy always conserved. Energy always constant. Changes from one form to another form. In our present case, freely falling body, how energy conserved means energy, kinetic energy. Kinetic energy convert into potential energy. Otherwise, potential energy convert into kinetic energy. The topic we are getting from this one. So, law of conservation of energy, freely falling body. What is the meaning of conservation? Energy neither created nor destroyed. Energy changes from one form to another form. That is the meaning of statement of this law of conservation of energy. For statement, you can get 1 mark in annual examination because in scheme of evolution, parts marks you are getting. Statement, energy always conserved. Energy changes from one form to another form. Energy always remains same. Any example, any word, no problem. So you write like lower class definition only. Energy neither created nor destroyed. Energy changes from one form to another form. This is the statement of law of conservation of energy. Energy always constant. In the case of freely falling body, for this one, I am drawing one diagram. See students, this is the diagram because diagram compulsory. M is the mass of the body. One more. Total, we are taking 3 different position. A, B, C, like this. Freely falling body means like this, not like this, like this. Drop. Freely falling body means body moving towards ground under gravity, just like this. Dropped. Freely falling body, total height of the body from ground to A point, small h. This height you treat capital H. One is the small h from A to B. Ground to top of the point A, small h. From ground to B point, capital H. What is the gap means? Small h minus capital H. Because total value minus this balance, we can get h minus h. Finally, from this one, we are getting energy conserved. Point number 1, nothing but point A here. Body dropped like this. Body dropped means obviously initial velocity equals to 0. So initial velocity u equals to 0. Why we are taking like this means body dropped, body falling freely. That's why u equals to 0. We are calculating kinetic energy half mu square. Few members they are thinking kinetic energy formula half mv square. But why we are taking u means u stands for initial velocity. Starting situation, initial velocity. Remaining all situation, you take final velocity. So initial velocity obviously 0. U equals to 0. U equals to 0 means kinetic energy equals to half m into u value 0. Kinetic energy equals to 0. Because u equals to 0, every term 0. Potential energy means m into g into what the height h, mgh. Kinetic energy equals to 0 and potential energy mgh. Total energy we are calculating kinetic energy plus potential energy. Energy at a point, kinetic energy means 0. Potential energy means mgh. Overall, we are getting EA equals to mgh. Question number 1. First question, 19th bit students, I am saying number also. 19th purpose, you are getting one LAQ from mechanics zone. Total 2 questions possibility. One is the law of conservation of energy with bullet problem. Second one is there work, kinetic energy, work energy theorem. 2 problems we are having. One is the power of motor in horsepower. One more ordinary power of motor, students. So point number A, before this one, this question starts from statement of law of conservation of energy. Energy neither created nor destroyed, but energy changes from one form to another form. Point A, we are calculating 2 energies. One is the kinetic energy, second one is the potential energy. Kinetic energy, U stands for initial velocity 0. So obviously we are getting kinetic energy 0. Potential energy means mg, height of the body, small h. Overall we are getting energy at A point, mgh. This is the A point. Next point B. Point B here. Point B means here. So with respect to this total displacement and with respect to this height, total we are calculating 2 energies. First of all, kinetic energy equals to half mv square. Suddenly we are writing v square. What is the reason means initial velocity 0 because body falling towards ground, effect of gravity. Remaining all situation, final velocity present half mv square. We don't know what is the v square. So v square we are calculating from equation of motion. You know, from v square minus u square equals to 2s. U obviously 0. A, body moving towards the ground, A equals to plus G. And what is the displacement means? H minus H. This is displacement, this is height, both are different. H minus H is the displacement from A to B. So we are writing V square minus 0 to body moving toward the ground, A equals to sign convention plus G. And what is the displacement means? Small h minus capital H. V square equals to 2gh minus capital H. Kinetic energy formula half mv square. Kinetic energy equals to half mv square. What is v square value? 2 into g into h. 2gh. 2 into g into capital H. Again 2gh. Half m, you take 2g common, student, h minus h, 2 cancel, mgh mgh. Plus into minus, minus, again capital mgh coming. This is the kinetic energy from point B. And one more, potential energy. Potential energy means potential energy means at B point, m into g into height. What is the height of the body means capital H. So we are writing m g capital H. This is the kinetic energy, that is the potential energy. Overall, we are writing EB equals to kinetic energy plus potential energy. mgh minus capital mgh plus mgh. So plus minus cancel each other. What is the remaining step? EB equals to mgh. Equation number 2. Equation number 1, equation number 2, both are same student. EA equals to mgh. EB equals to mgh. Last point, point C. Here, again we are calculating kinetic energy, student. One is the potential energy, second one is the kinetic energy. Obviously, height 0. That's why we are writing first v square minus u square equals to 2s. V square equals to 2 into a means plus g. What is the displacement means from top to bottom? It traveled small h displacement. So we are writing 2gh. Now v square equals to 2gh means kinetic energy equals to half m v square. Half m v square means 2gh. 2 to cancel. mgh, kinetic energy is equal to mgh. Potential energy is equals to m into g into what the height of the body on the ground means 0. That's why we are writing mg into 0, total value 0. Now we are writing EC, kinetic energy plus potential energy. Kinetic energy plus potential energy means kinetic energy already we got mgh, potential energy means 0. Overall, we are getting EC equals to mgh. So equation 1, equation 2, equation 3, energy same, energy constant, energy conserved. That's why we are writing from equation 1, 2, 3, energy conserved. Okay, students. So one more time, I will give you rapid explanation. First, law of conservation of energy, freely falling body. Statement: energy remains same, energy constant, energy conserved. All this one same meaning. Way of writing definition in examination: energy neither created nor destroyed, but energy changes from one form to another form. Here statement. We'll take one body mass m. M is the mass of the body falling from A point. This one freely falling body. So m is the mass of the body falling from A point. A 1 point, B 1 point, C 1 point. We are taking from A to ground. What the height means? Small h. From B to C, capital H. Gap h minus h. Point A, point B, point C. We are calculating what is the total energy. Total energy means sum of kinetic energy plus potential energy. U equals to 0. Initial velocity at A point. U 0 means obviously kinetic energy 0. Potential energy mg into h, height, over energy at A point 0 plus mgh. We are getting mgh. Same from point B. We are calculating kinetic energy v square value. We are getting 2g into h minus h. This is nothing but displacement, student. And what is the kinetic energy means? Half m v square.